In this video, I'd like to do 3 examples where we find the domain range of a function given its graph. So here I see a function y equals f of x, and I've been asked to find its domain and its range. Well, when I think about the domain, what I want to think about are the x values that have outputs, right? That's what a function does. It turns an x into a y. You plug in an x, you get an f of x. So I can just kind of think about, the x-axis here. And if I hold my pen vertically, anywhere my pen then hits the function, right, that tells me there's an x going to a y at that point. And so from left to right, the first x value I see that's in the domain is right there at 1. That's included. Every time I see a filled in circle, that filled in circle means that's on the graph, that's included. All right, and then after that, all of these x values, everything between 1 and 2, right? Even here, right? There's a point up there. So I just look from left to right, and all of those points are on the graph. My pen's hitting the function somewhere saying this x is assigned to that y. And then that finally stops when I get over here, and over here there's clearly not anything, but right here there's an open circle. And so that's where my domain stops. I go from 1, 2, 3, 4, 5, 6, and at 7 my domain has stopped. I use a parenthesis, because every time I see this open circle, that point's not included. But we use that symbol, that open circle, to let our readers know that everything before we got to 7 was included. 6.9, 6.99, just not 7 itself. If we don't use an open circle there, we might not be able to tell where this blue line segment stops. And so I found my domain. The domain goes from 1 to 7, including 1, because there's a filled in circle there, and not including 7, because there's a open circle there. So now let's find the range. I need to think the same way. This time, instead of moving from left to right, I'm thinking about bottom to top, and when I think about the range is the y values. Now, the difference between the domain and the range is each x is assigned to only one y. When I think about the range, there might be spots like this where, all right, this y value comes from 2 different x's, and that's perfectly fine. But I'm looking for the lowest y value on the graph, and so again, now I just turn my pen this way and kind of go up this way. Down here, y equals minus 1 is where that open circle is. That's not on the graph, but everything past that is. So I'm going to not include the minus 1, no point there, but even if I go just a little bit above it, like just down here at minus 1, you go boop, and there's a point on the graph right there. And then there's always a point on the graph until I get up to this line segment, and then it doesn't have anything anymore. So all these points have a y equal to 1, 2, 3, 4. So my range starts at minus 1 and goes to 4, not including minus 1 and including the 4. So we found the domain and range for this function f. So let's try another example. All right, let's call this function y equals g of x, and the instructions are the same. Let's find the domain and range. I usually use d and r, and if I only have one function, that's fine. If I wanted to be more specific, I could put a little subscript g, d sub g and r sub g, and then whoever's reading this knows, hey, that's the domain of g and the range of g. All right, so let's think about the domain moving from left to right across the x-axis, and I see the first place right here, minus 2, and that's included. And I see all these points in, but when I get right here, that point's not included. 0 is not in the domain. I have to leave it out. And so I go from minus 2 to 0, and then I stop, and then after that I pick up again. And so from here I go from 0 to positive 2, which also gets left out. And because there's a single value left out here, we use a union symbol between the two pieces, because the domain is minus 2 to 0, union 0 to 2. It says things stuck together. So for domain ranges, when we have more than one piece, we can use a union symbol. The range, we're going to start at the bottom and go to the top, and I see that y equals 0 is the first thing in, and we might be hesitant because there's an open circle here. But this point is on the graph, and it does have a y-coordinate of 0. So 0 is in the range. And then I go up, and everything from 0 to 1 is in there, and from 1 to 2, but when I get to 2, that point's not included. There is no point with a y value of 2. So that ranges from 0 to 2, and not including the 2, right? Because that's not included. 1.9, 1.99, 1.999, those are in the range, but not up there at 2. All right, so one more example in this video. We have one more function here, and this one's called f of x again. So we're going to find the domain of that function and the range of that function. And this one looks really weird. This one's going to have some hops and breaks in its domain and range. But again, let's look from left to right for the domain and from bottom to top for the range. Well, from left to right, the first x value I see is right here at -3. Except for there's an open circle there, so I'm not going to include it. All right, all these x values are in there, and when I get to here, I might think I need to stop, but then I realize that I don't need to. Because if I go just a little bit further towards 0, past -1, those points are also in the domain, so I don't stop there until I get right here. All of the points between -3 and 1 are in the domain. Then there's a gap. There's nothing in between 1 and 2. All right, so the domain stops at 1 and then starts again at 2 and goes to 3. And so there I have a domain with a big chunk missing in it. The range, I'm going to go from bottom to top again. It looks like this open circle's down here at -3 on the y-axis. And I go up for a while and all these values are in the range until I get to -1. And then it looks like they stop for a while. And then what I realize is that this line segment, horizontal line segment here, has one y value for the whole thing, and that y value is 1. There's nothing between -1 and 1 in the range, just that one value at 1. So I need to figure out how to write down a single value in this range. And what we do for single values is we list them in curly braces, that symbol for set. So the y value of 1 is all by itself in there, and then the y value of 2 at that other horizontal line segment is in there. And so that's how we annotate that. And that way there's no confusion, because I can't write this, because that would say all the points between 1 and 2 on the y-axis, including 1 and 2. I definitely can't write this. That would mean all the points between y equals 1 and y equals 2, but not those 2 points, and those definitely aren't in the range. So I just list those single values in those curly braces. Do you know what? That was going to be my last example in this video. But I'm having one of those moments where I want to do one more example. So I'm going to quickly draw a function, and then we're going to go through and do that one more example together. Oh, and I think it'd be a neat thing to do if you're watching this video to pause it as soon as I'm done sketching the graph and try it on your own before I do it in the video. It's always a nice thing to challenge yourself to give a problem a try before someone else shows you the solution. So pause the video here. I'm going to call this function y equals h of x, just so I've done something different. We're going to find the domain of h and the range of h. Pause the video here, give it your best shot. I'm going to put a solution on the board as soon as you unpause the video. All right, well that's where I fake pause, hoping that you actually paused the video. If you didn't, that's okay too. Let's find the domain and range. So we got filled in circle here, open circle there, open, open, filled in. And so I'm going from left to right, and I think, well, -4 is definitely where I need to start, and that's going to be a parenthesis with that open dot. And I get to -1, I have that thing again where it kind of jumps, and everything to 1's in the domain. There's a gap until 2, and then I go all the way until 4. There's my nice, happy domain. Now let's think about the range. As I hold my pen this way, the first y value I see is at -2, and that's definitely in the range with that filled in circle there. And all these y values I get here, and there are a whole lot of points with this y value, but that's still okay. It's just a value in the range until I get to 0. 0 is not included, got an open circle there, and now I have the situation where I have a single value here. The y of 1 is in the range. So from -2 to 0, including the -2, not the 0, and just the y value of 1. All right, so there were 4 examples of finding domain and range from a graph.